Hey, I want to show you the calculation. Some of you are having trouble finding tau and finding the theoretical temperature. So, in your Excel file, you will see column A, which is the time, and column D is the temperature. Okay, so this is the cooling curve. So, first you need to find the dimensionless temperature, which is temperature at time t, which is this one. T naught is the lowest temperature in the Excel file. This is 7. In your Excel file, you will have different data. Always pick the lowest number. This is T naught, right? Divided by Ti. Ti is the highest temperature, initial temperature. This is 100 for this file. For your Excel file, this should be different. Then, yeah, you will put this formula. I put like C6 is the temperature in column C minus I3 is T naught, then I divided by I2, which is 100 Ti minus I3. Okay, then just drag them. Yep, so here you see you plotted the experimental dimensionless temperature against time against dimensionless temperature. Because it's a dimensionless, you see the value is from 0 to 1. Okay, now the time constant tau, as I said in the if you see in the class, I was showing the formula here. There tau is like you have to find how much time it took to cool from initial to 63.2%, which is, if you consider 1 minus 0.632, which is 0.368. So this is 0.368, right? So you will draw a line, then you will extend the line to horizontal x-axis. Okay, so you will see that tau is here 1.5 second. So we find our tau is 1.5 second. Now you will put this tau value into the equation that I wrote on the board, and you have to find the theoretical temperature. So if you solve that equation, this is the formula. Okay, so then you will drag this to get the theoretical temperature. Yeah, so you see this temperature experimental, there were no decimal points, so we had some kind of error. The curve was not smooth, you see. So our data recorder, it did not give us any decimal point. But when you calculate the theoretical temperature based on this tau 1.5 second, you are getting the decimal points and the curve will be smooth. Now to plot again in this plot, you need to find the dimensionless temperature, right? So here I again put the formula. Now my temperature is E6, which is the theoretical. So the previous one I used C6, the experimental temperature. Now you are using the theoretical temperature. So click, drag them, and you should find the theoretical temperature. You see the red line is a smooth curve, and it has the same tau, because you used the same tau value, right? 1.5 second. Yep, so that's the thing I was asking you to do. So do this for all the four, J, T, K and E. Okay.